Good morning, Year 9. This is Mr. Essa once again. So today we're going to discuss about energy transfers. The energy transfer lesson will have three parts. First, we have this introduction. The second will have efficiency. And then the third will have Sankey diagrams. So first, we're going to discuss the introduction for energy transfers. Today, our lesson objective is to discuss energy transfer and success criteria. I can discuss that energy is transferred during events and processes and give examples of energy transfers. Let's have a short recap about energy. Energy is the ability to do work. The SI unit of energy is the joule, which is also equal to 1 Newton meter. Here are the different forms of energy. First one, we have kinetic energy, which is energy in a moving object. Gravitational potential energy, it's the energy due to the height of an object. Elastic potential energy, energy in a stretched or compressed object. Chemical energy, energy contained in food or fuel. Electrical energy, energy in the flow of electrons. Nuclear energy, energy released when the nucleus of an atom splits. Light energy, energy given out by any hot object. Sound, energy given out by vibrating objects. And heat, energy contained in any hot or warm object. Now you have to remember these are just a few forms of energy. The most important thing that we need to remember about this lesson is the law of conservation of energy. It states that energy cannot be created or destroyed, but only changed from one form into another or transferred from one object to another. Basically, we're going to explore how energy stored from one object is transferred to other objects by different processes. The different processes of energy transfer are the following: by mechanical work, by electrical work, by heating, and by radiation. Let's explore some processes of energy transfer using some examples. First, we have which device goes with which energy transfer process. This question is asking you, using torch, electric bell, and electric motor, what energy transfers are happening within these objects. So we are going to match them with these. Now you have to remember that the starting energy will be equal to the end energy that we'll have here, because according to the law of conservation of energy, energy is neither created nor destroyed. So all of these, kinetic energy, sound energy, and heat energy here will be equal to the input energy, electrical energy, accordingly. But now we're going to match which one of these has this kind of energy process, transfer process. So here we have electrical energy to kinetic energy, sound and heat energy. Which object has this transfer? And we have the second one, electrical energy to kinetic energy and thermal energy. And finally, we have energy transferred as sound and thermal energy. Which one is a transfer? Which one is an object that has this energy transfer? And finally, chemical energy to electrical energy to light energy and heat energy. So we're going to find out the answers. So now we're going to find out what the answers are. First one, we have the electric motor. It's from electrical energy to kinetic energy, sound, and heat. Now you have to remember that heat here is like a loss of energy, but it's lost to the surroundings, so it doesn't mean that the energy is lost. It's not, it's just transferred to the surrounding area. Now we have the second one, electric bell, because we have a clue over there. We have energy transferred as a sound in the final process. And then the last one, of course, we have the torch, because we have the end process over there. We have light energy and heat energy as our end process. So here are the answers matching the objects with their energy transfer process. Example number 2. Write down the energy chain for this power station. It's asking us to ignore the losses for this time, because we're going to discuss the loss of energy when we go to efficiency and Sankey diagrams. So let me show you the power station first. Here's the power station. So it shows us the boiler of the power station, and then somehow in this process we have hot steam, and then it'll go to this part of the power station, and finally we have a product over here and product. These are wires connected to maybe some homes or industries. So what do you think is the answer for this? Here's the answer. So it starts with chemical energy, which is stored in coals. Then it is transferred as thermal energy in the form of hot steam. And then the hot steam will create kinetic energy to the turbines like a windmill. And then finally, the energy will be transferred electrically, and then it will be transported or transferred to our homes. So this is the answer for this example. Question number 3 is a multiple choice question. Which energy transfer takes place when a matchstick burns? So this is quite easy. The answer will be chemical to thermal, because a matchstick has a store of chemical energy in it, and then if we rub it against a rough side of the match box, then we'll have thermal energy. If it also has like chemical to thermal to and light, then that's also the correct answer, because it also produces light energy. Example number 4, a ball is at rest at the top of a hill. It rolls down the hill. At the bottom of the hill, the ball hits a wall and stops. So which energy changes occur? Is it A, gravitational potential energy to internal energy and to kinetic energy? Or is it B, gravitational potential energy to kinetic energy to internal energy? Or C, is it kinetic energy to gravitational potential energy and then internal energy? Or D, kinetic energy, internal energy, and gravitational potential energy? Is it? So we have to analyze that. Let's say here is your ball. Now you have to remember that it's at a height from the level ground. Okay, so now we know that it has GPE, gravitational potential energy, and then it will go rolling down the hill. Now if it starts rolling down the hill, then we know that it's kinetic energy. Why? Because it's moving. So as it rolls down the hill, there'll be kinetic energy, and then finally there's heat produced because of the friction against the ground. So we don't have heat over here at the last part, but then it is actually internal energy also. So our answer here will be letter B, gravitational potential energy to kinetic energy to internal energy. Now here starts your work. You're going to answer these questions in your notebooks. A handout will be also given to you. You can answer there if you want, and then stick it in your notebooks. So you have 9 questions to finish. Here are they. And don't worry if I'm scrolling through, because I'll be giving you handouts for this. Okay, so let me just start again in case you want to do it in this video, and note your answers down in your notebooks afterwards. So number 1 is here. Which energy transfer takes place when petrol is burned? Number 2, what is the main energy change taking place in the battery of a mobile phone or cell phone as it is being charged but not used? Work number 3 is a situation, and then you have to analyze the energy transfer and type of energy which has been transferred when the load comes to rest. This is a spring bouncing up and down, oscillating. Number 4, electrical energy may be obtained from nuclear fission. In which order is the energy transferred in this process? Number 5, which row gives the energy change in a battery and the energy change in a solar cell? Number 6, a helicopter takes off from the ground and rises vertically. It then hovers at a constant height above the ground. Which sequence of energy change takes place during the gain in height? And work number 7 again is about a spring. Number 8 is a hydroelectric power station. Which row gives the name of the stored energy and the name of the output energy in this situation? And number 9, there's a diagram that you have to analyze, and then you have to find out the main energy changes taking place. So here are your questions. It's basically easy. When we go to efficiency and Sankey diagram, then we're going to discuss about energy losses. These examples are in ideal situations where energy is not lost in the system itself. So what have we learned today? We learned that energy is transferred during events and processes, and give examples. And we gave examples of energy transfers. I hope you enjoyed this lesson. This is Miss Teresa signing off.